Hello all and welcome back. So in this module, we are going to start with a new data structures, which is trees. So let's get started. Now, till now, we actually have learned lots of data structures and understood that how data structures are way to store the data. So we have seen how linked list, array or list and stack and queues are working. Now, in the overall way, underlying data was stored in some way, right? In stack and queues, we were storing the same in using linked list or our list. And the benefit was that it was helping me to perform some operations very fast. And in use cases, when I'm just performing those operations, of course, the choice of that data structure is going to make my program or overall my product a lot more efficient. Okay. One more thing to notice here is that till now we have seen that data structures can majorly be divided into two types. So one is primary. So primary is when we are changing how the data is stored in the memory, right? For example, if we see an example of arrays or linked list, in this, the way data was stored, that was overall different. In linked list, we used to make a node and then connect those nodes in the backend one by one and make sure that we have the head node. Similarly, in arrays or list, the elements they were in sync in a continuous fashion, change in a memory as compared to let's say how a variable store those values, right? Few of them are actually derived. So derived one are the stack and queues, which were actually implemented using arrays or linked list in the backend. So we were not changing actually the way data is stored. We were just restricting some operations and making sure that few operations are a lot more efficient, right? Now they are in a way layer above our basic data structures. Okay, so they are just defining how data is accessible to user. We are just adding a layer about this primary data structures. So I can write stack and queues here. Great. So trees is actually an example of primary data structure where we will be changing the way data is stored. Now, the reason we are studying trees, or rather we study any data structure, is that in problem, few of the data can be better represented by some data structure and thus be acted upon in a better way. We have, of course, discussed this many times that how we can maintain 100 variables instead of making a list or an array, but we might not be able to work on that efficiently, right? Also, one more thing which I would like to notice, which I would like to tell you here is that till now, all the data structures which we have studied, the inbuilt one, right? We were not a lot focused on how the complexity is working, how the different operations are happening. But when you get deep down into DSA part of it, we are actually a lot overall paying focus on how the data structure performs with respect to complexity, something which we will see when we study hash map going forward as well as in trees, right? So we saw that how our main aim is to make sure that every data structure, along with helping me to store the data, it should be efficient as well in its operation, right? So always remember this thing as well. That's the reason importance of data structure is so much, because you are focusing on overall complexity as well. Okay, so great everyone. Now let us understand with trees. I'm pretty sure that discussion would have helped you to get a little bit idea on how we are, why we are learning about so many data structures. Okay, great. So trees is actually a non-linear data structure. So let me write that down, non-linear in nature, and it is used to represent hierarchical data. Hierarchical data. Now we are going to study trees in three parts. The first one are going to be generic trees. Then we are going to move to binary trees. And then finally the binary search tree. Now I have seen many resources, but have not seen someone who is in a way explaining trees in such way. I believe that this will be a lot helpful in expanding your horizon, plus making you understand that how we come from trees to a binary tree, then to a binary search tree, instead of directly jumping into the last two variations. Okay, great. So let us see the definition of trees. Trees is a hierarchical data structure consisting of nodes which are connected by edges. There can be a lot more complex definition as well, but I think this is as straightforward and easy as it gets, and it can help us to understand. Now, of course, again, I don't want you to focus on the definition part majorly. I want to understand the implementation or the application part, right? Now, let's think of a hierarchical data. We can actually think of family tree for an example. So, how does family tree works? Let us see. Let's say we have a overall starting where we can write great grandfather, right? Great grandfather. Then under him will be, one second, let me do it nicely. So let us have few notes so that we can use them while I explain you. Okay. The very first thing you will be noticing is that this is a hierarchical data. It is having some levels, right? So this is some kind of a data which might not be that easy to implement using the current overall current overall data structures which we know. So let's say now this is great grandfather. So here let's say is grandfather, right? Then let's say grandfather overall has four childs. And here this person has one more child. Okay, so I'm just writing child one, child two, child three, and child four. And let's say this can be the grandchild. So just to make it a little bit easier to get, we are going to use this terminology. Again, we are going to see lots of example. But if you see this particular data, you will understand two things. It is hierarchical in nature. The very first thing, there is a hierarchy, right? There is a level. Then under that, there is a level. They are connected by each other by edges. And I can say that they are the nodes, right? Now, this kind of a data is not that easy to represent by using data structures which we know. Like, of course, you cannot make them represent by an array or list or even by a linked list for that matter, right? Stack and queues again are the overall derived data structure only. For example, this particular grandfather, he's having four children. Okay, so there is no guarantee that only one node will be there, right? So this kind of a data, whenever we are given, that is where we can say that, hey, a trees can be used. Okay. And just like in linked list, we had the overall head node. We say that here I will get the root. So root is going to be the node from where it all starts. Okay. Now, many of you might have a doubt, which I even had, that why is this being called tree? Normally, the way we see tree, it is something like this, right? Let me draw it a little bit nicely. Yeah. So normally when we see tree, it is something like this. This is my tree, right? And then there can be some roots overall. So there is the roots, right? So to, in a way, understand this terminology, what you can do is just see it in this way. Okay. So what I have to do is just see it in this way. We are just making it upside down. So we have this root here, right? So everything starts from root. Starting from root, we have the branches. We have the different branches. Let's say one branch, two branch, third branch. Then these branches can have more branches. So the way I'm asking you to imagine is something like this. So let's say this is the root. Then there is the one branch. This branch can have further branches going forward. Similarly, this branch can have further branches going forward. And finally, the end at leaves. So we are going to learn about these terminologies as well. But that is the basic intuition on why we call it as a tree. Plus, you will see that how, in a real life sense, family tree and all these examples like organization chart, where let's say we have a CEO at the top, and then let's say some director, something is under him. Those are also known as tree, organization tree or something, right? So that is the basic idea behind this terminology and why it is called tree, because everything is starting from root and then it spreads across in a branch. like structure, right? Which we can see in this particular example as well. Again, the intuition is very important, everyone. Don't remember anything. Just understand that why this is an upside count down kind of a tree. So we are just saying it like this, tree like this. Okay. So just we have upside down it, right? Something like this. I hope that helped you to imagine it a little bit. Okay. So that is where this tree terminology comes in. And few of the terminologies which we will learn going forward, they will be analogous to tree as well, like leaf and node and all these things. So yeah, that was the basic introduction about trees, everyone. In the next video, we are going to just dive a little bit deep into this and understand on some examples, the practical use case, as well as where it is used in industry. And of course, then moving forward, learn about terminologies and implement the same just the way we did for other data structures. So let's meet in the next video.